And yet in healthcare, when it comes to actually getting information, I think each and every one of us, we're all, starting out with our family, our community, talking about the importance of data in healthcare and so on and so forth. And lastly, and part of that is looking at the ethical and legal frameworks, in terms of how the data is being collected, used, and implemented. And importantly, supporting local startups, looking at applying AI in healthcare with industry and providing that research input to all that we do. So I'm going to actually not stop there, but since we're here, just so that you're aware of who we are, what we do, and certainly St Vincent been very happy to support this inaugural event. We're part of, St Vincent Melbourne is part of a national group, a $2 billion company. We're actually the second largest healthcare provider in the country, and it's the third largest private owned company. And this is all of our sort of capabilities. And there's about 27 sites along this eastern seaboard, in Brisbane, Sydney, Melbourne, and we work closely with industry, running a lot of trials and so on and so forth. And it's just to highlight some of the projects that we've got at the moment. For example, there's a project looking at mammogram images, working with breast screen, in terms of better diagnosis and so on and so forth. CA Medical, which is one of our spin-out company, and it was great to see some of our team members here. And it's really looking at leveraging or using data to with patients with epilepsy and how to actually, doing predictions and modelling and so on and so forth. Had some work with Bupa looking at, again, ways to optimize our data set and looking at ways how we actually run services. LBT Innovation is one of the projects. I might have heard of the company, but they're looking at using imaging analysis to actually looking at cell cultures on agar plate and speeding up the process, creating more sort of accurate predictions and so on and so forth. ShareRoot is a company that we partners with, looking at using social media data to actually drive clinical trials, improve recruitment. Stryker is an orthopedic company, but that's more on the robotics, and there's certainly AI is included in that. Anyway, I'm not the main speaker for today, so we've got two speakers, which I will load up the presentation. First up, we have Associate Professor Sandeep Reddy. Yeah. Okay, so a brief introduction. So Sandeep is a qualified medical doctor. He's now an associate professor with the Deakin Medical School, and really sort of qualified in a lot of areas, including medical informatics, management, public health, and recently he's really focusing on teaching research in healthcare management, public health, and really looking at the application of the evaluations of technologies in AI, in healthcare and hospital management, and authors of a couple of books too. So if you could all join me in welcoming to Sandeep to the podium. And so the format is Sandeep will go first, followed by Owen, and then we have a chance to have questions at the end. Sandeep.
I don't like to be behind the podium. I just want to check if Alicia in the back, you can hear me. All right, great. So before I go ahead, I would like to pay my respects to the traditional custodians of the land, the Wurundjeri people of the Kulin Nation. So as Tam explained, the format is for me to commence my presentation, and then Owen will follow, and then we'll have some time for question and answer sessions. So we want to keep aside quite a bit of time for question and answer sessions. So what am I going to talk about today? So there's been a lot of hype about AI. There's been a lot of news about AI. There's been a lot of misconception about AI. So my role here is to set the ground truth. One is to talk about what is AI, so that we all have a common understanding of the technical understanding of AI, and then propose the case for AI. Why should we use AI in healthcare, and especially now? And I'll also be looking at how AI gets applied in healthcare, and then we'll project into the future and discuss how, if AI is incorporated in the healthcare system, what the health system would look like. And as I said earlier, we'll have the question and answer sessions after everyone's presentation. Okay, so why do we need to consider AI at this stage? Before we actually answer the question, let's look at the issues facing healthcare. By no means those ones are the comprehensive list of all the issues that face healthcare, but I've picked out the important ones. So the first one is the cost. So not all realize when we talk about healthcare spending, the largest amount of costs go towards hospitals. Just in the US, it's about $1 trillion per annum. And that is exponentially increasing every year because of workforce costs, because of recurrent costs, not just because of infrastructure costs. And the second issue is access. And I talk about access, not just financial access, but also geographical access. People who live in regional rural areas are not necessarily getting the same level of care as in those in urban areas. And the third one is workforce shortage. The amount of time it takes to train medical specialists is especially long. And also there is, when you do get become a specialist, there's a certain amount of time that you require to operate autonomously. So that time, considering the demand, there's a mismatch around that. And then the other issue is interesting. The type of care you get in Melbourne for the same condition is not the type of care you will get when you go to a hospital in Perth. And even sometimes within the same state, you get different cares depending upon the physician, depending on the hospital, depending on the infrastructure. So that variability care is there. There's no real standardization of care. The last one is really, really, really concerning. So John Hopkins did a study a while ago, and they published in BMJ, estimating that there were about 250,000 people who die of medical errors. And this was published in the BMJ. Since then, there's been some challenges to that particular number. They said some of them have questioned the methodology because in ICD coding, there's no real code for medical errors. And because of that, there have been some question if that figure is accurate. But that, even with that correction figure in the response, it was about 25,000 deaths per annum. So that's still a large number. So keeping aside AI, keeping aside any technology, we do have an awareness that health service definitely has issues. And if that wasn't enough, now we have this aging tsunami. It's projected by 2100 we'll have 3.1 billion people who are over 60 years. Right now, it's about 1 billion people of 7 billion people. That's quite a large number. So what does it mean in terms of healthcare? What it means that health services have to adapt their care models, their treatment pathways to the growing aging population. We need to respond to geriatric disease like osteoporosis, bladder incontinence, Parkinson's, dementia. I can go on. So you see, and also our workforce is not really prepared for this aged population. So we need to reorient that. And that's very costly and time consuming. And if you think that wasn't enough, you have this big elephant in the room, the chronic disease, which the World Health Organization terms as the biggest challenge our health systems face. And the issue with chronic diseases, it's not something like an infectious disease. You treat it, and then you give some antibiotics or put the person in the intensive care or give them necessary treatment, and the person walks out. It doesn't work that way. Some of them are lifelong diseases. And some of them also have comorbidities. They are having multiple chronic diseases. So in terms of care itself, it's quite complex. And if you look at the amount of money that is being spent in Australia, it's about $25 billion per year. So, and that's increasing because we are having more and more number of chronic diseases, especially diabetes.
They're not working now. AI is take over.
Out of that.
Yeah. I'll turn off all the microphones so Google's not listening.
All right. So maybe you're rushing a little bit because of the time constraints. So if you feel like you really want me to slow down, I'm also happy to clarify during the question and answer sessions. So now that we got the perspective about the issues facing health services, and I can go on all day today talking about the issues with health services right from the population system, right from the population level, right to the individual hospital level. But you get what I'm trying to say, that there's a lot of issues that health services are facing, and they are pretty much running out of solutions. And I propose AI is a solution. And why AI? Before we get to that, let's first get an understanding of what AI is, because most of us get information about AI from the media, and it's not necessarily a credible source. So let's get a proper understanding of AI. To understand AI, we need to understand intelligence. So if you look at the root word of intelligence, intelligere, which comes from Latin, it means understand. So in terms of AI itself, we're really looking at a computer-based intelligent agent. What is an intelligent agent? An intelligent agent perceives the environment and takes action in relation to that. And this is a visual illustration of what an intelligent agent is. So environment could be anything. It could be just the environment around us, or it could be anywhere else. And in relation to that, through its sensors, it perceives it, and then it takes action, and through the effectors, it actually reacts to that. So if somebody says their software is AI, they necessarily have to have an intelligent agent. If not, it's not an AI software. Having considered that, now it's quite easy to understand what AI is. So it's basically computers simulating human behavior, or computer software incorporating an intelligent agent. And now, one of the things people think that AI is new. It's not necessarily. It's been around quite a few years. Some people trace it back to the time of Aristotle, the concept of symbolism. But modern AI has been more than 70 years. So you must have heard of Alan Turing and his concept of Turing test. But if you talk about neural networks, even that has been around for a while. McCullough and Pitt described the first concept of a neural network. Both of them are neurobiologists, not necessarily traditional computer scientists. So you can see the intersection between neurophysiology, neurobiology, and computer science. But it's only lately that we start to hear about AI. Why is that? There are really a couple of factors. There have been in the past hype about AI. If you talk to people who have been in AI for 20, 30 years, they say, oh, not again. But the point is that around that time, we did not necessarily have the infrastructure. And talk about infrastructure, I'm talking particularly about graphical processing units. And in the past, graphical processing units were developed for gaming purposes because they can crunch huge amount of data, especially images. And then when they started to develop convolutional neural networks, which required to crunch images, they found that the graphical processing units could crunch the data much better. And the second factor is the availability of big data, volume, variety, and veracity of data. There's huge amount of data. Traditional algorithms, even traditional machine learning algorithms, were incapable of crunching the data. So neural networks really, really helped in that way. This really brought about the re-emergence of AI. The third factor, which is not there, can anybody say that? Can anybody identify what it is?
Cost.
Money. So now we have many government services, health organizations investing into AI, which really help research into AI applications. Okay, that was very quick walk through what AI is. Hopefully by this time you sort of get a feel of what really AI is, what is not AI, and what is AI. But now let's look at what's the types of AI. And this is quite confusing. If you look at even standard textbooks of AI, like Stuart Russell's and Peter Novick's standard textbook of AI, which is being used in all computer science and applications, they don't even define types of AI. And then you look at what's being circulated in journals, literature, even then you get confused what exactly the types of AI. So to simplify that, I've just identified three categories, and some of you may not necessarily agree with that, but for the purpose of today, I think it makes sense. So the most commonest form of AI that's being used, whether in healthcare, whether it's in aerospace or farming, any other industry, is machine learning. And then you have the advanced form of machine learning, which is neural networks. And the second type of AI is reinforcement learning. This is pretty a new phenomenon. You must have heard of DeepMind's AlphaGo, and they use reinforcement learning. The third one is robotics. Again, robotics has been around for a while, but the use of AI in robotics is new. So we'll briefly talk through each of the types now. So what is machine learning? I can give you a textbook definition and you'll forget it by the time you walk out of here, but I'll direct you to this slide where you'll see where in traditional programming, that's normal computer programming, you feed in the data, you feed in the algorithm, which is the rules, and then you get the output. But in machine learning, what we do is we feed in the data, and then we feed in the results, and the machine itself devises the rules. That's why it's called machine learning. It's based on pattern recognition, so it recognizes patterns in the data and devises the rules. Why is that useful? It's useful when we face a tsunami of data, a huge amount of data. We don't necessarily have to sit down and make rules for each and every situation or context. The machine itself can start making those rules. All right, so that was machine learning, but what are the types of machine learning? And it's very simple. There's two types, mainly supervised learning, unsupervised learning. It's really, really easy to remember this. So with supervised learning, basically the big data that we have, the data we have, we label the data. And in unsupervised learning, we don't label the data. We expect the computer itself to organize the categorization or the clustering. And there are further subcategories which will take up all of today, which I'll not go into today. I remember I told you earlier, we have big data and then we have an advanced form of machine learning. So as I said, AI has been around for a while. AI really, pre-neural networks, there were traditional classical machine learning algorithms. But they were devised around symbolic rules, symbolic expert rules, expert systems. So for those who have been working around that, can recollect that. For that, you had to actually sit down and manually devise the rules if and when. And when you came across big data, they didn't necessarily work. So with the advent of neural networks, that issue has been addressed. So what are neural networks? So neural networks are a form of algorithms which are fashioned around the structure of the brain. For those who have got a medical background, a health background, imagine you got a neuron, you got the axon, you got the dendrites, you got the synapses, and they're connected with each other. That's how these are. So those circles are neurons, and they're connected with each other through edges. And based on fine-tuning the weights, you get the results. So one of the issues Irwin's going to later talk about, the issues with deep learning is the lack of explainability, lack of interpretability. Why does that happen? If you look at the architecture, you will see in between the hidden layers. And the data, when it goes through it and the results come out, even the developer itself can't decipher the decision-making process. Nowadays, there are some solutions like Lime, SHAP, and other things which are emerging, but really, truly speaking, nobody can wholeheartedly say that they can explain the decision-making process. They can guess, but not say that. And whereas I've got some solutions with that, but that's not for today. So why do we prefer neural networks compared to traditional machine learning algorithms? One of the beauties of deep learning is that it can extract the features itself. You got heaps of data and you don't have enough resources. And then you run through the data with deep learning, it starts to categorize and feature the data, feature extraction itself. So that's one advantage over regular classical machine learning algorithms. So how do we actually develop AI models? Doesn't matter what type of algorithm you're using, naive Bayesian algorithm, random forest decision tree, support vector machine, Boltzmann machine. There's a common pattern. You acquire the data, clean up the data, structure the data, and then you split up the data into two parts. Test category, test data, training data. So with the training data, you run through the training data to the algorithm, and once you achieve the necessary results, you validate it against the test data. You can go a step further and validate it against external data, which is called external validation, but generally they follow these rules. This is restricted to machine learning. It's not so much the case for other types of AI. Okay, that was machine learning. I know I'm going very fast. That's mainly considering the time and leaving aside time for question and answers. If you seem to struggle with some of the concepts, very happy to address that in the question and answer session. So quickly running through the last few types of AI. So reinforcement learning. This is gaining a lot of buzz nowadays because of the success of DeepMind's AlphaGo and then there was Alpha Zero, and then there was another one, Star something I can't recollect the top of my head. So how does this reinforcement learning work? So the way you train the agent is basically run through a stage, and then depending on the outputs, you reward or punish it. It's like a trial and error sort of process. So basically, the agent learns to maximize the reward, and that way, through that process, it actually achieves the state you want. So there's much more to that. There's a lot of mathematics around that, but that probably gives you an idea of how reinforcement learning works. If you forget everything I said, just remember trial and error. Now, robotics. So, for those of my generation, remember preparing robotics with electronic circuitry. That's not AI at all, though some people may dispute that. What I'm really talking about, use of intelligent agents within robots, that's embodied AI. And that's really, really picking up. And if I was a betting person, I would put my money on robotics more than any other AI type, because this is something that can really, really pick up a lot of manual work that we're doing, a lot of repetitive work that we're doing. But not only that, when you look at what's happening in Japan, it can also provide social companionship. So robotics can be one of the topics we can go on about today. So just to summarize, what I'm really talking about is embodied AI and AI in robots. Now, let's come to the topic of today and my proposal why we should use AI in healthcare. We already talked about the case, so the need for AI, but how exactly do we use AI? So, use of technology in healthcare is not new. If you think about X-rays, they've been around for more than 120 years since Wellington really used it. And since then, there have been ways of technology, use of technology in healthcare. Now we're talking about the fourth way of technology, which is AI and big data and machine learning. And just like the history of AI, which has been around for a long time, the concept of using AI has been also around for quite a bit. William B. Schwartz, more than 50 years ago, proposed the use of intelligent agents in medicine. Since then, people have, in line with the development with neural networks, have started to borrow the concepts. Earlier, what happened was they used to use a symbolic or expert systems. So expert systems, you basically, as I talked earlier, you have to devise the if and when rules, and that really didn't work with complex clinical data. But now with the emergence of neural network, that issue has been resolved. So there's re-emergence of interest in using machine learning. Of all the industries, farming, real estate, social security, pretty much every industry uses AI directly or indirectly. So I can't, truthfully, nobody can say we are not using AI. Even as individuals, so our smartphones use AI anyway, or when we're watching Netflix. But of all the industries, if you look at where the greatest amount of activity is happening, happening in healthcare. And why is that? Because health is so important, and not only that, from a tech perspective, you get huge amount of data. Just an average hospital can produce 665 terabytes of data, and the World Health Organization estimates that by another 20 years, we'll be having petabytes and exabytes of data. That's 10 to the power 18 amount of data. So for that data to be analyzed, there's no way possible or regular algorithms, regular computer software can work on it. We need machine learning, and some people have even proposed quantum computing, but that's a topic for another day. So where do we use AI? As I said earlier, we're already using AI in our smartphones. We use AIs for nutritional coaching, voice-based coaching, for mental health applications, for predictive modeling, social networking from a consumer perspective. And from a clinical application, which is really exciting, is we have medical imaging processing, which we'll talk about shortly. And then we have clinical decision support systems, and using electronic health records as ontologies, we have non-knowledge based clinical decision support systems. Not just in the health space, but from a back end, which is really, really happening a lot in the United States because it doesn't require FDA approval, because we're talking about administrative purposes, billing, reimbursement, supply chain management. And now if you think all that is really, really in theory, look at the number of applications that have been approved by FDA for clinical use. Just in that slide, that's only for 2 years, there's over 27 there. And since then, there have been another 10 which have been approved just on the top of my head. So every year, FDA, which is the regulatory authority in the United States, is approving AI applications for regular clinical use. Most of them are in medical imaging, but you also have some of them as clinical decision support systems uh, and other kind of areas. Okay, if I actually start to talk about each of the applications, we probably will be still around even tomorrow. But I'd like to focus just on three aspects, which will probably give you an idea of the power of prowess of AI, and probably rest my case in that we do need consider AI. So first one is where a lot of maturity has arrived is medical imaging integration. And truly speaking, if you know the technical side of things and you know the application side of things, you can put a hand on your heart and say that we are ready for use of AI in medical imaging interpretations. The other ones, a little bit of controversy. There may be some questions around that, but yeah, we'll talk about that shortly. So, what is clinical imaging analysis? So, in terms of using computers to interpret X-rays, MRIs, CT scans, they've been around for a while. But with the advent of convolutional neural network, which is the algorithm which is showing a lot of promise in analyzing spatial hierarchy or images, that's really helped picked up use of AI in medical imaging integration. So how does a convolutional neural network work? I know some of you are already dozing, but bear with me. This will really help you pick up your spirit. So the way it works, convolutional neural network, it's not just on images, it works on other data too, but it's really powerful in picking up images and converting into a flattened vectors by passing it through a layers, convolution layer, pooling layer, fully integrated layer, and a softmax layer. So what it really means in lay language is it's picking out the important parts of the images and identifying the target classes. So in case of this one X-ray, say for example, you have a pneumothorax, collapsed lung, it's able to identify that. So why is that important? A radiologist can do that. But not all health services can afford a radiologist. And when you have radiologists, you have volumes of X-rays, volumes of MRIs, volumes of CT scans. You physically can't be able to go through it. This convolutional neural network or an AI application can help you shortlist that, can help you pick up the ones which you need to focus on. And convolutional neural networks have really picked up in many ways, not just with X-rays. It's a multimodality application. It can pick up images from many other things. Some of the applications that they're using in X-rays or in MRIs, they're actually been trained earlier on cats and dogs, and they use a process called transfer learning, and then just fine-tuned it to that particular modality. So this is another using heat maps as the outputs. So any of those conditions that are listed on that slide, pneumothorax, atelectasis, pneumonia, cancer lesions in the lungs through X-rays can be identified through CNN. The most interesting one, and which has really created a lot of buzz, and is actually being used autonomously in clinical working applications, is use of convolutional neural networks for identifying diabetic retinopathy through fundoscopic images. So these kind of images are not necessarily interpreted by radiologists, they're done by ophthalmologists, but the underlying basis process of analyzing images through convolutional neural networks still stands true. So if you look at the way we, the way we assess the performance of AI algorithms is something called receiver operating characteristic area under the curve. In other words, for those who are familiar with epidemiology, on the y-axis we are looking at true positive, and the x-axis we are looking at false positive. And the closer the curve is towards 100, the larger the area covers, that means the performance is much better. So you look at any literature of AI, this is what they use as performance. There are other subtypes like F-score, true positive value, and so forth, but this is a really good way of assessing the performance. So here you can see the performance of that autonomous algorithm to assess diabetic retinopathy is nearing to 100 and even exceeding the performance of ophthalmologists. This was the Google one, which is currently being used in India in Shankar and Anand Netrala hospitals. So that was in brief convolutional networks, medical imaging interpretation. Convolutional neural networks can be used on text too, can be used for analyzing data from electronic health records, but that is where the maturity has been achieved. So now let's talk about clinical decision support system. How are we doing with time, Tim?
So putting another maybe 10 minutes.
Okay, 10 minutes.
Yeah.
So I may have to really rush through a couple of things, but let's just focus on the key important aspects. So, clinical decision support systems, for those who have been in health informatics, know there are two types of clinical decision support systems. There's the knowledge-based clinical decision support system, the old type of clinical decision support system, and the newer form, which is based on AI, is the non-knowledge-based clinical decision support systems. So, what is the difference? Knowledge-based clinical decision support systems, again, it goes back to that expert systems where you manually code if and when rules. Thinking about the number of clinical guidelines being produced in a year and the amount of clinical knowledge, medical knowledge that's emerging, do you think it's even possible to actually utilize those kind of systems and keep up to date with what's happening? So that's why I think the promise of using AI, non-knowledge based clinical decision support system, is very enticing. So if you talk about that perspective, using AI as an inference in the inference engine, so within clinical decision support system, there are several parts. The inference engine is the driver, that's the engine. Here you can see an illustration of clinical decision support system being used to support the treatment and the management of chronic obstructive pulmonary disease like emphysema and chronic bronchitis. So you can see the decision engine driven by support vector machines, artificial neural networks, decision trees, or an ensemble of all of those things. Another place where we can use clinical decision support system, drawing upon multiple source data, lab value, electronic health records, and so forth. So I think of the two couple of emerging applications. I think we have really seen what AI can do for medical imaging interpretation, and I think the next phase will be focused on clinical decision support systems because in the US, there is a lot of discussion on how physicians are getting burnt out by the use of electronic health records. And we'll talk about that in terms of the NLP itself, but also in terms of enabling them to make better decision processes and keeping up to date with medical knowledge. I think there's a lot of promise for clinical support systems. And now to the last application. When I say last, just for this presentation, AI is much more than these three applications. So is NLP. So what is NLP? NLP is natural language processing, where computers interpret human language, written or oral. And thinking about the context I described earlier, where physicians are spending out of the 11 hours they work in a hospital in each day, they're spending about 6 hours documenting everything on electronic health record. The beauty of NLP is that it can actually be able to take up most of the work and reduce the amount of burden. So how does it actually do that? How does it actually work? So it again works on various AI algorithms, interpreting textual data or oral data, which is quite complex to describe. But I just wanted to highlight these particular applications where the accuracy levels have achieved that are close to precision rates. So what it shows that is NLP applications are also achieving maturity levels which weren't seen before because of the use of neural networks. And if that was quite abstract, I'll give some examples that you may recognize. All of us have heard about Babylon, the controversy around Babylon. So Babylon is basically outsourcing triage 4 and 5 screening out to the software, out to the public itself. So it's also helping identify conditions through symptom checkers. And the counterpart in the US is Sensely, which is a virtual nurse assistant. It's not very well known, but it does the same kind of function as Babylon. And Babylon claims that in terms of the symptom checkers, it meets the competencies of GPs and nurses. That's their claim. It hasn't been independently validated. So that was a quick Captain Cook's tour through what AI can do in healthcare. There's much more than that. As you can see, one of the exciting areas is robotic surgery. I'm not talking about Da Vinci surgery, which is not AI surgery at all. What I'm talking about, truly autonomous robotic surgery. There are already trials being held in the US for suturing, laparotomy, and all of those kind of things. And we're going to be starting to see more of those happening in the future. And this part I'll probably quickly run through because of the lack of time. Let's project ourselves 20 years from now. How would an intelligent health system look like when we start to incorporate AI? So as I mentioned earlier, there's a lot of promise in using clinical decision support systems They'll be integrated into regular clinical workflow. We've got to be aware of automation bias, but think about certain areas where clinical decision support systems could help. So we could see that integrated. There's patient monitoring and coaching. Patient monitoring, especially in ICU, there's already quite a bit of literature studies which have shown the usefulness of AI applications in sepsis, severity scoring and sepsis alerts. So that's possible. Then we'll have more of those automated devices, not just in the hospital, but elsewhere too. Administration we talked about is already being used, but there'll be more advances in that. Robotic assistance. So this is not necessarily into the future right now. In Japan, they're already using robots to provide social companionship for elderly people, but also do some of the manual tasks in hospitals. In fact, you'd be greeted by robots in some of the hospitals in Japan. So examination room, this is quite interesting. Nuance, which is a US-based company, they recently demonstrated an intelligent clinic where you would walk into the clinic, the patient would be recognized by facial recognition technology. All the details of the patient would be coming up on the screen through electronic health record because of the recognition. And then the doctor doesn't necessarily have to look into the computer or type anything. Everything is being transcribed. So all the manual tasks which the doctor would do or currently is doing is taken up by the intelligent health system, and all the doctor needs to do is supervise and oversee that and sign off on the record. So that's already happening. So it's not even into the future. So we'll have more of health analytics beyond the hospital in epidemiology. Even in the recent Ebola outbreak, AI played a role. So we'll start to see more of that. What I didn't cover today was drug discovery because it's really takes a lot of time and resources to actually identify new molecular compounds. And by the time it is discovered in the lab and it reaches the clinical environment, takes about 10, 11 years. So it can accelerate that process. And that's why a lot of pharmaceutical companies are hiring data scientists. We talked about this. Okay, now let's get back to the reality. So if somebody would come to me and say, can you really tell me where exactly there is value for use of AI in healthcare? I can confirm that use of AI for medical imaging, we are there. It won't replace radiologists, it won't replace the ophthalmologists, but it will definitely augment their work. We are truly there in terms of use of AI with medical imaging. Of course, there's some criticism about people being able to hack into the systems, being able to create issues with that. But from a general perspective, we are there. Looking into the future, as I said, there's going to be a lot of work on clinical decision support systems, and 25, 30 years from now, I think we're going to be seeing a lot of remote and robotic surgery happening, and possibly even an AI clinician appearing for the clinical exams. All right, summary. We looked at the challenges, so I think most of us are in agreement that healthcare does have challenges, and I propose the case of AI. Some of you may agree, or some of you may not agree, but I think there is definitely a value proposition there. So if that really generated some interest, I direct you to two of my books. So the first book is already available on Amazon, and it really is written for a general audience. It's a quick read. It charts the progress of AI from theory to application. Right now available on the Kindle store. But for those who are want to know more in detail and academically oriented, there's a textbook of mine coming early next year, published by Taylor and Francis. This got contributions from all over from the world, from MIT, from Harvard, from Stanford, from University of Melbourne, University of Adelaide. It's really in detail, so watch out for that. Thank you so much for your attention.
Thank you, Sandeep. Before I move on to the next presentation, maybe encourage you, and that's hard to sit and listen, so maybe turn to the next person to you. 30-second, one thing that from Sandeep presentation and what questions you're going to ask him while I'm doing this. So free to talk now. Let me just find the presentation. So that's pretty quick, isn't it? 30-second is really fast, and I'm at the risk of letting the audience talk and not coming back, but I'm sure you will. So our next presenter is Professor Owen Lowe, who's a Group Chief Clinical Officer, and he's a clinical professor at Monash University. Also have an honorary appointment at Macquarie University. Owen asked me not to read his bio, which I won't because it's very detailed. But needless to say, he's a qualified medical practitioner, both in general and specialist in medical administration. And he's also a barrister and solicitors.
Still reading.
Well, it's very important. This is important. You cover both medicine and law. But Owen's going to talk about the ethical and medical legal implications, which is quite interesting. So join me in working with Owen.
So in the Middle Ages, you know the history when the doctors that were around at the time were physicians, and they refused to basically touch people. They were cognitive physicians, cognitive specialists, and during the Middle Ages, when the knights were battling one another and they were getting cut open and they were getting limbs cut off, it was really the butchers and the dentists who were doing all the suturing. And that's really an example of how medicine has evolved. Because today, surgeons will argue that actually they are the people who are doing things that physicians can't do, right? They're all mainstream now, and that's really my interest. So what got me into looking to futurology and the future of medicine is really the evolving role of doctors in health. And since then, I've been kind of looking at this. I've done with my own research. I'm by no means a technician or an expert. I'm not a computer scientist, but that's kind of led me to looking at how AI is going to impact health. My original training was in psychiatry, and it got me looking into AI and the role of AI in mental health. But one of the things that we know is in 2016, they did a massive meta-analysis and systematic review of 50 years of research in suicide prevention. And the conclusion was that all the research that we've done in psychology meant that we were only able to predict suicide by chance. It was the flip of a coin. We can't actually predict suicide. But when they looked at, when they applied machine learning algorithms across electronic health records, they were able to actually predict suicide at 92% accuracy in terms of whether someone was going to commit suicide in the week after, just based on a medical record review. And so AI has applications in health. I think Cindy's provided you the basis. But that means, though, that when we start to predict things in health, there are ethical and legal implications. So when you apply AI using functional MRI, we are able to predict suicide. I won't go into detail, but now Facebook, Twitter, a lot of the social media companies are now applying AI algorithms across the posts to try to predict if a poster has a risk of suicide so that they can actually redirect them to health. That's happening now. So in prediction of suicide in particular, you look at the literature, there are really two branches. There's medical prediction and then there's social prediction. So Facebook's moving to social prediction. Again, there are ethical and legal implications. But AI now can actually predict if someone's going to get Alzheimer's on brain scans, but also on speech. How someone talks in terms of speech pattern can be predictive of whether someone's going to develop dementia. They can predict if someone's has a risk of psychosis just based on speech patterns. And I'm just giving you an example of speech. Whether someone's depressed, speech pattern, whether someone's got PTSD. So again, this is just a small subset of how AI can predict. And in fact, controversially, some people have argued that AI can actually predict just based on your conversation with your partner whether your relationship is going to survive or not. And this is about the number of we words you use. The more words we as opposed to I, that's apparently predictive. And the other area that we kind of touched on was robotics. But sex robots are actually coming in. There's a lot of media around it. But the whole issue of if you use a sex robot, is it infidelity or is it just using a sex toy? But there is a whole area of consent with sex robots. It's quite interesting. If a sex robot becomes artificially intelligent, can they refuse? Can you harm it? because there are people who are saying, can actually cause harm to it. And then there's a whole issue of pediatric or child sex robots. There are laws being enacted across different jurisdictions to outlaw this now. Then AI can be applied in other areas as well. Here in Japan, they are trying to use AI to predict, to kind of see if you are going to shoplift or whether you can shoplift. But then, there are things about in the US now, different jurisdictions are using AI to try to predict areas of crime. This is literally happening in the US, where there's a company called PredPol. This is called predictive policing. Different policing areas are now looking to predict where crime is going to happen based on all sorts of data, including weather, car accidents, whatever it might be, to then reallocate sources of police resources. You can now predict whether someone's going to die based on multiple factors. There are quite a few studies on this, on chest X-ray, CT scans. This is on the biobank in the UK, just based on your genetic risks and then your lifestyle risks, your health records. They can tell if you who's going to live up to a certain age. Now, all these things I'm sharing with you have all sorts of implications. So now this is another kind of controversial study which has generated a lot of discussion. This study got people's photos, and if you ask people to kind of guess, is this person gay? People were, not very good, 61, 54%. This is not based on dress on the face, right? But an AI they claim to predict, this is a Stanford study, 91% or 83% better. So this is better than just humans being predicting just based on the face whether someone's going to be gay. Highly controversial study. There's a lot of issues with this. But clearly, on the one hand, there are some applications here. So the worry that people have when it comes to this kind of prediction is how are we going to use it, right? So on the one hand, if you're using it to improve my health, great. But then we all know this is a bit like personalized medicine and genetic studies, right? It tells you your risks. It doesn't tell you you're gonna be this, but you're gonna have a risk. Medical insurance can use it to fight fraud, but obviously then medical insurance can use this to take away insurance, right? So if it's one thing to use your genetic information to say you have a genetic risk of something, but if they then use AI to look at your lifestyle, to look at your health records, to say actually you're at risk of being, it's one thing about health, but you're at risk of being a thief. You're at risk of performing, carrying out crime. There's lots of implications. In China, in particularly, people have heard about the social credit score and the sources of surveillance, facial recognition. They're already using this in a very real way in China. And in China, they're taking away people's insurance just based on the algorithms that they are using in terms of facial recognition software and things. But Sandeep refers to the deep learning, the neural networks, and the fact that it's a black box. So it's one thing to use an algorithm where you program it to say, if A equals B, you do C, and then you can kind of understand because you've given it the rules. But in deep learning and using, there is an unconscious level of coding so that when the AI reaches the conclusion, you actually don't know how it's done that. And this is a big problem at the moment when you start to use AI in real life cases to make decisions. So in America, for example, in the UK, in both the UK and the US, they're now using algorithms for social services. So in the UK, there are examples where they will get an AI to review someone's history, records, big data, and then decide, yes, you are eligible for social housing, for example. This is real. And then it might be the AI then decides to reject the application. It is really difficult to appeal against that because who is accountable? How has the decision been made? In the UK, this is literally published a couple of days ago. There's also, The Guardian's published this whole series of articles around the fact that in the UK, they are spending a lot of money implementing machine learning and AI to make decisions because they're hard decisions to make. There are a lot of decision points. But the fear is that because the UK are trying to the department's trying to save money, this is going to lead to more claims of social services benefits being declined. The other thing that we've touched on, but there's a real thing is on privacy. So people remember a few years ago in the UK, DeepMind got into trouble because the NHS shared data with DeepMind. As we all know, health information is there. The primary purpose is to help the person, but then they were starting to use it for research and for other purposes. They got into trouble. You would think that DeepMind would have learned, Google would have learned, but they came into trouble again just recently this year in the US. Same thing. So for AI to learn in its data, and the more data you give it, the better it gets. The problem is that the data is your information, my information in health. It's our health information. So have we consented? Do we want to share our data with an AI and a company, a private company? So that's the implication. So Tam made a joke about switching off Google, but this is the other part of privacy. It's the reality is that we are providing information all the time, and we have kind of signed away our consent in a lot of ways. So every time you use Google search, every time you use a phone, and the reality, I mean, you didn't know, the mic on your phone's on all the time, because when you say, hey Siri, it knows, right? So it's on all the time. It's listening and it's processing what you're saying all the time. And you will recall a few weeks ago only, Google, Apple, Amazon, they all got into trouble for collecting your voice recordings and for then letting third-party contractors listen to it to teach its AI. So this is another real issue that's happening. So privacy is a whole area of ethics and law that we can unpack. And this is the other area that is emerging now, is deepfake AI. People heard about it. So in America, in particular, they're really concerned about the 2020 elections, because now you can use AI software, and it's off the shelf now. You can just download it. It's open source to create videos that look real and put other people's face on it. So they're being used. It's being used in politics, being used in porn. So it's a real issue, and that's one of the problematic areas that AI can be used in. The other issue with AI in terms of the law is IP, right? So, like I was referring to, a lot of the algorithms that you can use now is open source, openly shared. OpenAI, Google, IBM, they all have repositories. You can download it literally. So I've got medical students who are very clever, who are creating all sorts of interesting algorithms. So they obviously own the IP, but obviously then they're using a lot of IP and code from other people as well. But then what about IP then that's created by AI though? So there's an interesting case here where an inventor created an AI algorithm, and then the AI algorithm has gone on to, by looking at what's out there, looking at what gaps there are, looking at what's been designed, has designed a new color, a cap, and a new kind of burner thing. And the inventor is saying, I want to claim a patent, I want to apply for a patent, but I want to give it to the AI. And when the patent office said, well, you can't give it to her, because it's not a legal entity, you can give it to an AI. The inventor has argued this, so this is going to court as a test case, because the inventor is saying, I didn't come up with it. It's kind of like me supervising a medical student. It's not my idea, it's the AI's idea. It's a completely novel idea that's been generated by software. So this is an interesting test case. So again, this has opened up a new whole area of law. The other part, which is very relevant for clinicians, is the whole issue of liability. So when we start using AI and robots, and if something goes wrong, who's liable? Who's going to be sued, right? At the moment, an AI is a tool, it's an instrument. So clearly, it's the easiest thing to say is that the clinicians are at fault and potentially the hospitals are at fault. But it becomes very complicated because once AI starts to become much smarter, once AI then, once the software tells you that we have looked at all the evidence, human beings cannot possibly know all the evidence, we've done it, this is the gold standard treatment. So it's just like evidence-based guidelines. If you don't follow it, you need to have a reason, right? Because it might be that you're negligent by not following the advice from the AI. So this is relevant with clinical decision support systems. The other thing as well is that AIs are, at the moment, software itself doesn't have legal personhood. So in the EU, they've argued this actually. The EU is now moving towards giving AI entities some legal recognition, just like companies have. So, as we all know, corporations have legal entity. You can sue a company, although companies have directors. And they're not real, they're not investors. So in the same way, they're thinking about creating a structure in the EU. So they debated it. It's not to and fro. It'll be interesting to see what happens. In this case, there was an investor who trust, there was an AI, even as we all know, in share investing, AI is now emerging, it's outperforming humans. They trusted an AI, they lost a lot of money, and then they're trying to sue. Who do you sue? Because it was the AI who gave them an advice. So again, it's an emerging area into the liability. It becomes an interesting point because the ethical issue here is, who is making that decision? Because when it comes to the trolley problem, people know about the trolley problem, right? Who do you if a train's coming, who do you kill? Do you kill 5 or do you kill 1? It's less of 2 evils, right? This becomes a real issue. In health, you might not think, hang on, this is not really relevant in health. The clearest example is in self-driving cars, right? So as self-driving cars become more mainstream, become smarter, it becomes a real issue because if there's an accident, who do you hit? And do you save the pedestrian or save the driver? Because sometimes it might be that to save the pedestrian, the driver dies. And some researchers have argued that the decision has to be the driver, and there has to be an ethical knot. So some drivers are more more self-preserving, selfish. They'll say, save me. Some drivers might be altruistic and selfless. They say, save the pedestrian. But it becomes a real issue, and I'll touch a bit about that a bit later. But the other thing that we kind of talked about was bias, right? So, and because when AI only, especially the newer forms of AI in terms of deep learning, machine learning, they're learning, right? And the classic saying, rubbish in, rubbish out applies. So if they learn from bad data, they're gonna come up with junk. So there was a nice science study that they got a machine learning algorithm to learn from the internet, Wikipedia, and Google, and just like Tam was saying how put in a search on Google, some of the search results might be quite biased, might be quite racist or sexist. This is exactly what happened. The AI became racist and sexist because humans are racist and sexist. So if you give it data from humans, it's going to be like that. So that's part of the inherent bias that can exist. There's how it's coded and what data you give it. So this has been a real issue with the Watson AI, actually, which you can talk about later. So MIT kind of did an experiment. They created this algorithm. They call it Norman. They sent it to learn from the darkest part of the internet. So the darkest subreddits, the dark net, and it became psychopathic because it just learned the worst parts of humanity. And you can actually go onto the website and kind of ask it questions, because if you ask it questions, it's going to come at you with really dark things. So again, an interesting experiment, but it kind of makes you think about, what happens if AI gets to learn to be bad. And this is why, Stephen Hawking, before he died, he did talk about the fact that we need to have regulation around it. People like Elon Musk, a lot of people have talked about the fact that, we need to be careful, in particular when it comes to robots that are applied in the military, and this is a real thing now. So, and I'll tell you why this is relevant in health, right? So in the military now, they have robots now, and it's going to be a real thing. They have autonomous drones and tanks, and it's all happening. And so this is literally this week. There's a whole massive campaign now at the UN to say, just like chemical weapons, nuclear weapons have been banned, we need to ban autonomous weapons because they can be dangerous. And because of this, right? I don't need to say further, but how this is relevant in health is this, right? So it's a great analogy. So in the military at the moment, there are autonomous drones flying around. It may be flown by a person, but may be automatic, right? And then it will tell you, we have found a target. Give us the instruction to kill. And so a human presses a button, kill, and then it kills, right? Now the military at the moment is contemplating taking out that step. Because it's telling you to kill and you kill, but why have the step? It's quicker for it to just kill because the person might run away, right? So there's a small step, and people are kind of playing around because they're already doing it, right? They're already grenades and bombs where if it senses someone's close, it will explode. Right? So no human intervention. So it is already kind of happening that machines are making a decision to kill. But this is a more obvious thing. So the relevance in this in health is this. Sandeep referred to robotic surgeons and how Da Vinci is not really robotic surgery, it's not autonomous. But the Da Vinci founder is trying to create a second version of Da Vinci, which will be autonomous, right? So there's already studies. This is the STAR robot in 2016, suturing better than humans. And then in 2017, same robot, cutting better than humans. But it's still kind of under human control. But what if that robot, again, takes the next step and then decides, I'm going to cut without, because it's going to be cutting better than us, or, if it's going to cut out the shape, cut out the joint, it's going to do it by itself. So no human intervention, right? So similar to this, right? And it makes a mistake. Well, I didn't tell it to do it, right? So who's at fault there? Now that becomes an interesting question. So at the moment, humans are kind of still in the decision-making kind of chain of command. But that's kind of like an emerging area of law. So then is it the vendor? Is it the software programmer? Is it the person who's given it the machine learning information? Or is it the AI? Can it be legally liable? Is it always going to be the doctor? Is it the hospital? I mean, that's the arguments that will be had when the first error happens, which hasn't really happened yet. So what has Elon Musk decided to do to keep up with super intelligent AI that he believes is going to happen? So he's talking about people have heard of Neuralink. So earlier this year they published this paper. And so Facebook's trying to do the same thing, but Facebook's trying to do it using EEG. And again, they've got investing a lot of money into this. Elon Musk Neuralink, they published a white paper earlier this year, and then they actually published it in a peer-reviewed journal as well. So they have a proof of concept. They've got a mouse now that can control a cursor on the computer, and they believe that this is the future. They're talking about direct interfacing. But again, this opens up a whole new area of ethics and law in terms of the ethically, it's bad enough that we have to look at our phones and we have to interact with something that could be addictive for some of us, that's bombarding us with ads, that's trying to influence the way we think. Imagine if that's a direct connection into our brain. Where does our thought begin and end? Where does, the whatever it is that's sending this information. So it's an interesting concept and potentially dangerous. And again, but just like any other technology, I'm not sure we can stop it. So then it's about as health practitioners, people working in health, what's the application in health, and how do we sort of govern this? So how do we govern it? People know Asimov's three laws of robotics. Do people know this? You read sci-fi, you know, a robot may not injure a human being, or through inaction allow a human being to come to harm. Fantastic. Must obey the orders given by a human being, except where it conflicts with the first law, and then must protect its own existence as long as it doesn't conflict with the first two. It's fascinating laws, and a lot of kind of computer scientists and philosophers have talked about the pros and cons of this. Obviously, now that we're moving into a time where this could be relevant, people have come up with 23 principles. This is a few of the leading tech people have come up with at the conference at the Saloma AI Principles 23, but there are actually different frameworks. Still no time to go through all of them. The EU recently came up with some guidelines around ethics. A lot of people are trying to work this up because ultimately now is the time to kind of think about this. How do we kind of come up with some coding parameters around AI now? As I say this, there are countries like China who are investing a lot of money in the AI and kind of now leading the way in many sense. They might not be concerned with any of this. So, we can talk about banning autonomous robots, but countries like Russia and China might just not care about that. So it is going to be an interesting future. So I'm going to stop here and open up for questions because I think this is where the fun bit is. But the discussion, I'll just say if you're interested in reading more in terms of future in health and AI, Michio Kaku and Ray Kurzweil are interesting people to read. This is me with a Michio Kaku doll. I'm a bit of a fanboy. And this is me getting Michio Kaku to sign the doll. He was actually here in Melbourne last year. So anyway, we'll move on to the questions.
Yep, right, thank you. So, what a journey. So starting with some very technical, and then Erwin, I was thinking, it's like, so the doctor will see you now, and it's also then all of a sudden the robot will see you now. And Erwin come along, it's like the robot's gonna kill you now. So kind of confusing. So questions, comments, please. Maybe I'll start up with the IP. There's people in the audience with IP background and law. Any comments on in terms of giving an AI sort of the legal entity? So I feel like we can adopt those little games that kids used to play. Now we can actually adopt an AI. Any thoughts, questions, comments?
I'll go.
Yeah, please.
So,
No, speak
fantastic.
louder, speak louder.
Yeah, thank you. So, fantastic presentations, both of you, and you were able to confuse us very clearly. So thank you. But in terms of, in context of Australia, I think it is absolutely evident that it is going to support, in terms of health industry, there are overworked staff and there is a geographical challenge and all the other things. But the thing which you mentioned about the policy of AI solutions, that is something which is not really coming out clearly from the government end, or maybe it's not coming out fastly enough. So what's your view on that?
Yeah, so Australia is really playing catch up at the moment, right? So in the US, FDA has already come up with a governance framework to approve algorithms based on AI to work in health. The TGA in Australia has just done that earlier this year. They've come up with AI as a software as a medical device. They just released that framework. Hospitals are also playing catch up. Now, the reality is that clinicians and researchers are using AI already. They're being approached by vendors, they're testing things, they're parting things, but it's being done with very poor governance. So people like myself, like Cam, we are trying to ensure that it's being introduced at the moment like a new technology or clinical practice, which is what it is. So at the moment, just like if you're gonna introduce a new device, a new instrument, new clinical practice, AI has to go through that process. We don't need to make anything separate for AI. It is a new device, which is what our TGA is looking at. And so it needs to be assessed on its merit. Is there evidence that it works? If not, should it be a clinical trial? If it does, what's the evidence? What's the cost? People have to be fully consented. So what we don't want is doctors starting to use all these interesting AI devices without any evidence that it works, just because the vendor wants to sell them a product. You know what I mean? So we just have to be careful with that.
Yes.
I've met with the MSA and the TGA earlier this week around that report. They'll be coming out again for consultation.
Great.
The distinction they very much were making was the one that you raised. Is the AI providing guidance to a human who will then make a call, or is the AI making the call? And they see that as the critical difference. But we were having a conversation earlier on. That's a fairly grey.
It is, isn't it?
Sort of area.
It is a grey area.
And I'm not quite sure how they're going to. I think it's your thoughts around validation, because the comment you made at the start, it's so hard to get the data. You need volumes of data for reliable AI. Your thoughts?
So we already have that tension today, right? When it comes to the analogy is evidence-based medicine and peer opinion, peer expert opinion. So what I mean is, NHMRC, NICE, whatever it is, have a good example is thrombo prophylaxis guidelines, right? You got to give heparin or taxane if it's this. They have an algorithm, a flowchart. If you don't follow that, you better have good reason, because if you don't follow that and something goes wrong, someone's going to say, well, that's the guideline, why didn't you follow it? And so you got to explain yourself, well, because this patient is an exception. Or similarly, if you don't follow best practice and then a whole bunch of your college tells you you shut down. So it's the same thing, right? So the problem with AI is that usually at the moment, and because it's not that mature, clinical decision support will tell you the best practice and kind of bring it together and say, this is the best practice. And then similarly, you'll be doing the same. You either follow or you don't, right? And so you're kind of in control. But there'll be a point when AI will make a decision, will give you a recommendation. And this is kind of can happen in oncology when it comes to very complex trials or rare conditions. When you don't really know, how did he come up with that? Because there were no guidelines, because it's rare conditions. And then you say, okay, I'm not going to follow it. And then something goes wrong and you get sued. Someone's going to say, well, actually, why didn't you follow the AI? So who made the decision? Well, it should be you, right? So, when AI, there's a whole discussion paper on when there will come a time, some people think, when you're not following AI, you'll be seen as negligent. And at that point is when that crosses the line, I think. I don't think we're there yet. I think AI is still supportive. But, there will come a time potentially when a human being will not be able to know the full spectrum of all the conditions, and the AI will tell you to do something, and then you have to be very sure, of yourself if you don't follow it. Do you know what I mean? I think that's a discussion that the TGA needs to kind of think about. At what point is it out of your control?
But also in terms of the medical legal aspects, in the US, big law firms are investing in AI. So basically looking at, for cases where you've gone through some procedures and treatment and they've been looking for it and actually come up with saying, actually, yeah, we're playing here. Work with us. I think that's a challenge. Yeah, we're playing catch up too.
It's a huge challenge.
Just want to put a shameless plug about a paper that's coming out. Myself, Paul here, and a couple of my academic authors publishing in JAMA, Journal of American Medical Informatics. It talks about the next steps. There's been a lot of discussion about AI ethics, bias, explainability, integrity. But what next in terms of a clinical environment? We talk about the clinical governance framework. So that's coming out hopefully by the end of the year.
Okay.
I was going to ask locally, and to follow up some questions I posted there earlier, we're one of the departments that has vendor approaching us around predicting hospital representation risk. So we've already gone through a bit of a journey with them in terms of unpacking which variables might contribute to representation risk, and then having a risk stratified series of resources that we put in place based on risk to reduce the chances of people bouncing back to hospital constantly. In terms of locally here, do we have any governance? Who owns the processes, the doors? Which doors do we knock on? Where do we start here at St Vincent's, Melbourne, in terms of the vendors that are approaching different pockets of the organisation, and who owns it? How do we enable these things to move forward?
So I answer locally and then Melbourne to sort of the national approach. But so I would treat it as a research project because they're going through, as Owen was saying before, going through validation. And so we need a clear governance in place, whether it's, it could be a trial, it could be a clinical research, or it could be some sort of service agreement. We've got to be clear about data ownership, and that, potentially they can use, our data to validate or to teach their software, but it comes to a point that, we have to have some sort of oversight of that. And so you can't just say, compare us with another health services or use that sort of against us or selling the data to third party where when it comes to the medical legal, someone coming in and saying, well, actually I wasn't stratified the right risk level and therefore I wasn't given the optimal care and therefore I'm going to sue. So, Owen,
No, I think at a group level, so at a national level, I think we are still on a journey.
Yeah.
We are no different to everyone else. We are playing catch up. And we just need to kind of keep up to date and get with the program. I think.
But also, if there's any sort of vendors out there, obviously you've got to work closely with us as well, rather than just the one way. So I think that's important. Not all sort of hospital research governance are bad or vice versa. It's just about sort of working together, because otherwise, at the end of the day, it's our reputation and your reputation as well.
Just want to add to that, it's really, really hard for entrepreneurs to get medical data sets. And what they're relying on is publicly available data sets. So really, really good medical data sets out of the United States. There's the MIMIC data set, which covers intensive care unit data sets. So we don't want necessarily institutions to create barriers for innovation. We don't want to put hurdles such that there's no ability for these entrepreneurs to access medical data sets. So that's one aspect. And the other aspect is in terms of technically, there's a kind of algorithm called general adversarial networks. What it does, it actually creates new data. So earlier, Urban talked about deep fake, deep images, those kind of things. They actually are responsible for that. So they're being used to augment data, to impute data. So that's another approach.
And so Sandy makes a good point. The data is the value is data. I mean, people say data is a new oil. So when vendors come to us, usually they actually say we want to work with you for free. Why? Because the value, we hold the data. They need it because that's what they need to teach. That's what AI needs is lots and lots of data. The struggle is the legal framework hasn't caught up. Plus, this is not people's housing data. This is people's health information, which is the most part of our data. So we can't just share it willy-nilly. In particular, with commercial vendors who might make money off it. So as public hospitals, in particular, we need to be custodians of people's data because this is why other organizations like the NHS have fallen foul of the law because they share in good faith data with Google, all their patient information, and Google has then used it for other purposes to teach us AI. So I get it. We need to help entrepreneurs, but on the other hand, we're not here to, breach people's confidential information and help other people get rich as well. I mean, we need to kind of then create a structure where if people are going to make money off us, we better have a license sharing thing, so that the public can benefit as well. Any other questions? I'm sure there are lots.
Thoughts and comments, please.
I'm going to struggle to articulate this. At the moment, when you release a software package, for example, it might kill 1 in 1,000 people, but the clinical practice might be killing 5. So there's a decision: is this actually better? Should we release it? With AI, with the governance that's going to be coming, is there kind of thoughts around the threshold of how good does the AI have to be before it's allowed to be used, both socially and legally?
It's a beautiful question because that's the exact question and struggle that people have with self-driving cars. I mean, I'm sure that's where the questions come from, right? So, and then now Elon Musk, Tesla have articulated exactly that, because we've read in the newspapers Tesla's crashing, people dying in Teslas, right? So they burst into flames, they've just driven into the wall. But we know that self-driving cars, even today, are safer than normal driving cars. So it's what's the level of death can society tolerate before we make it mainstream? Great question. So that kind of question is the same, to be honest, with any new innovation in health. Health in general is traditionally risk-averse, conservative. This is why clinical trials are so tight. We report all SAEs and all adverse events in trials. And if one person dies in a trial, we shut down the trial. I mean, that's because it's taken very seriously. So it's the same thing. So in that sense, AI really shouldn't be treated any different. Just because it's better doesn't mean it's great. So, and it's hard to know because, what is the death rate? So you're saying surgeons will kill, there'll be complications. So I think it's, in one sense, no one will be thinking about that really, because AI is less obvious. Like cars is really obvious. You're gonna hit the pedestrian, you're gonna kill the driver. In surgery, you have a complication rate and a death rate and mortality rate. And so in robotic surgery, you will have the same. So just like a human being cutting a vessel, there'll be bleeding and the patient might die. Robots will do the same. I think there'll be a rate, and I think people will just compare the two. It'll be that the problem at the moment is that if you're talking about robots and surgery, we don't have many randomized controlled trials in surgery in general anyway. We don't compare techniques. We really don't. It's all observational cohort studies. There's even less in AI than the very, very few randomized controlled trials. All the research that people have done on AI and health are experimental. Are the lab-based, highly controlled environments. There's very little real-world examples where it's working. And this is the struggle. So AI is just kind of moving into health, without a lot of strong evidence to show that actually is better than standard care. But it is happening.
And even in some of the approved, what's put up in some of the approved algorithm through FDA, it's a bit like trials. You actually, have to revise, look at the data, whatever, they run over there in the US, again, to your point about, garbage in, garbage out, some of that can create bias. They might have, certain patient population, and when it applies to our patient population, it doesn't actually, applicable. But I think to your point, in terms of looking at AI, how I see it can work, and I know that there's clinicians and surgeons in the room, AI in that regards can looking at the hospital-acquired infections and going through medical records and doing that prediction. So patient go through surgery, what's the chance of getting some sort of complication and putting, resource into dealing with that. And part of that is the data analytics assisting the clinicians actually looking at running other trials as well. This one here and then one back.
I'm interested in thoughts on how AI can be used in digital therapeutics, because often when we have meetings like this within hospitals, we always end up talking about surgery. And all the progression around devices ends up being about surgery and robots, which largely isn't fixing systemic problems which the entire world is affected by complex chronic disease. So if we can switch the conversation away from these marvellous buildings to think about where digital therapeutics are going, because if you look at organisations like WellDoc who've got their Blue Star product and how AI can be used to change behaviour. Because if we are looking to the future's not in robotics. It's more about freeing up space and time so that those patients can come in to have their acute situation sorted out. So where do you see AI, government's decision making? How heavily regulated does it need to be to ensure that the clinician still has that overarching control of the decision, but also balance that with the rise of consumerisation in health and the power of the patient becoming, in the future, 10 times more and beyond educated on why they're actually coming to the clinician to get a decision.
So the way I see it is, I think we start on a wrong basis. We have this term artificial intelligence, which I really don't like, but it's been so for so many years, so we just use that. So what American Medical Association has done is that rather than use that term, they have termed it as augmented intelligence. That really gives a lot of confidence for clinicians, for patients, is that it's not replacing doctors, it's not replacing the human oversight. What it's doing is augmenting the process of clinical decision making. I think that's the sort of thing we really need to approach. Talking about digital therapeutics, absolutely think there is a lot of scope for that. The reason I believe in AI is because of the democratization of healthcare system. What we currently have, whether in Australia or elsewhere, is information asymmetry. So that's why we go to the doctors, that's why we go to the hospitals to get that information. I'm not saying doctors are just conduits of information, but they are the repositories of the information, and we pay a premium to achieve that. So I think the value of AI commercially or from a health system point of view, from a population point of view, is able to get you that validated information, but at the same moment having some sort of step where serious cases, where there's high acuity cases, that they still are supervised by doctors or treated by doctors. On the other hand, the flip side to that is what's happening in the UK is that the rich and the digitally savvy people are using Babylon, and then they're identifying these conditions. I don't know if they are, kind of hypochondriacs or not, but it's what is happening is you're having a lot of people turning up at the emergency department. So I think we need to have a balance where there's low acuity conditions which could be treated at home and then supported by Internet of Things and remote telemedicine, and with the help of augmented intelligence. But going back to my point, I think we really need to start to think of AI in healthcare as augmented intelligence as opposed to artificial intelligence.
Anything to add?
No, I think your point's made.
Great. There's no further question.
There's one.
Oh, sorry.
So in Australia, who is the governing body
to set up those policies, like FDA in the US?
TGA, therapeutic use.
TGA.
Yeah.
So just in terms of FDA, before we end up, I know everybody's eager to get back. So what FDA has done is really unprecedented. The previous FDA Commissioner, Scott Gottlieb, hats off to him. He really pushed FDA to enable innovation and new AI applications. What they've done is the kind of framework they have is not only for the current sort of state of AI, but also looking into the future, evolving algorithms. So what they have is a process I think TGA or any other regulatory agencies can sort of borrow and learn from. Absolutely, if you've got the time, I would definitely look at the white paper that the FDA has released about governing and regulating AI.
Just one last one.
Sure.
Sorry, I'm keeping people over. What are the challenges in terms of AI going in wrong hands? Because that's where collaboration with our policing forces and all those things are relatively important. And I don't know if there's a view on that.
Well, I mean, it's like anything, it's like biological weapons, chemical weapons. It's like any other technology. It can be used for good or it can be used for not good, right? So I think, but like any other technology, once the cat's out of the bag, it's out of the bag, right? And it's like genetic engineering, CRISPR. People are using it now. You can buy it on the internet, right? So it's a similar thing. It's about what happens. How do you answer that? What are you going to do? As a society, we need to kind of be aware. We need to speak up. If governments are using it in a nefarious manner, like surveillance and invading your privacy, we need to oppose that. We need to come up with guidelines around the use of it. But I think if nation states don't use it in a malicious way, I'm not sure you can do much about it. This is about the UN's. That's why UN exists. They're trying to come up with an international framework. It's a good question.
Yeah, good question. Maybe next time. And on that note, I just want to thank you for your participation. I want to thank our speakers and our leadership team for putting this together, this inaugural event. If you haven't signed up to Meetup our group, so please do that. And then hopefully there'll be another event before the end of the year.
Yeah.
So thank you again.
We're also looking for speakers and sponsors for our next Meetup event. So any of us, please approach us if you have any ideas. Thank you.